Hi guys, so in this video we're going to give you a very short and concise tutorial about LaTeX. So the first question is, what exactly is LaTeX? So LaTeX is a typesetting language for preparing high quality documents, especially if you're working in the field of science. So it's really well if you're trying to prepare a mathematical paper or a presentation for your college, or could be your assignments, anything like that. So without any further ado, let's quickly begin with a very small tutorial for LaTeX. The starting off with, this is the homepage for the LaTeX project, which gives you a very brief history about when it was started, what are the latest news about it. And this is another page that I'm going to refer you, which is the Overleaf's official page, which is the best place where you can find documentation for tutorials and basic stuff about LaTeX. Right. So first thing you need to understand is there are two ways in which you can create a LaTeX file. The first thing is whether you want to do it online, and the second is whether you want to do it offline. So if you want to do it online, Overleaf is the best place that you can use. So all you have to do is go to your web browser and search for Overleaf. When you go to Overleaf, you can basically log in using your Gmail ID or other ways, whichever way you want to do it. And then you go over here, you create a new project, you create a blank project, write down the name. For example, I'll label it LaTeX tutorial. You create this, and after a while you'll see that you'll get the basic skeleton of a LaTeX file. So let's quickly go over this, and then we'll look at the offline version of it, which is where I'll primarily be doing my work today. So this first line basically tells you what kind of LaTeX document you want to create. For in this instance, we are creating a LaTeX article. After this, you'll see the second line, which tells you use package. So there are different packages required for different things. We'll come to that in a while. The next is probably the first thing that you'll see on this output page. So this left-hand side, this thing on the left-hand side is where you're going to write down your code. Yes, it's a coding thing. And on the right-hand side, you get your output in the form of a PDF. So the first line over here, the LaTeX tutorial, is basically this title line. So you can label it whatever way you want. Let me be a little fancy and let's call it the LaTeX tutorial. Yeah. So you can use Command Enter, Control Enter, or you can go over here and press on compile, and you'll see that there has been an update in the output page. So this is the official logo of LaTeX, and this is basically my new title line. Underneath that, you'll see this new line which tells the author's name. So my name is Shreyam Banerjee, so it'll display my name. If you want this date to be invisible, you can just delete the date here, right? And if you compile this again, you'll see that the date line vanishes, right? And if you undo it, if you want to keep the date, you can keep it like this. It'll show you December 2024. After this, we come to this begin document. So basically anything you want inside your LaTeX file is going to be in between these two lines. So begin document marks the beginning of your document, the end document marks the end of your document, right? So next line you see here, okay, yeah, we'll come to this error very soon. But before that, this make title line basically creates the title. So if you remove this, you'll see that this title page vanishes, right? So you'll see that the title has vanished. Right, now if I recompile this, you'll see that it'll come over again, right? Okay, so let's ignore this error for the time being. So this is a basic skeleton of a LaTeX file, right? Now, mostly LaTeX is used to create mathematical papers, presentation assignments, and mostly that, okay? So it's slightly difficult to prepare it in any other formatting space. For example, it could be, I don't know, Google Docs, it could be MS Word. It's slightly more difficult to align equations over there. Formatting might be a little difficult. That's why we prefer LaTeX over those languages, right? Or those applications. The first thing we'll do is, it's called a section. So what exactly is a section? It is exactly like the heading of a particular para or a particular slide or something like that, right? So the first section we'll discuss is mathematical equations. Right? So this is my first section. So in this mathematical equation, what we'll do is we'll see how do we actually write down mathematical equations in LaTeX. Now the first thing is, okay, let's create a subsection which is a subheading in some sense. So the subsection is superscript and subscript. Right? So if you see, you'll see that this is highlighted, and underneath that you get superscript and subscript, right? So in superscript and subscript, what we actually talk about is if you have equations of the form, let's say x square, or let's say we have equations of the form different variables x1, x2 all the way till xn, how do we write this in LaTeX, right? So for that, so if you want to write 2x square, what you'll do is 2x caret square, right? So over here it displays an error. But even though you can see on the right hand side that you can see this 2x square has already appeared on our output page, right? So why exactly do we get this error? This is because any mathematical equation that you write in LaTeX, you need to tell the source language or the compiler that this is actually a mathematical language, because after all, it's a coding language. You need to instruct it precisely. So for that, what we do is you need to write this equation between dollars, right? So this begin and end dollar basically tells the compiler that this is a mathematical equation that we are writing. And you can write normal sentences in English before and after that. For example, I could write, I wrote 2x square, let's say, instead of x square, right? So as you can see here, there are two mathematical terms or equations, whatever you want to call them. We have written that in this particular sentences and I've enclosed them between the dollar signs, right? But the normal text that I write, in general, we can just write it normally, okay? And LaTeX understood that and he gave this output that I wrote 2x square instead of x square, right? So this is the entire idea of superscript, right? Now what happens if you have some sentence in the power, okay? For example, the power could be slightly more complicated than square, right? So what if I want to write e power, let's say e power x square plus 2. Let's say I want to write something like this. Let's see what you get as the output from here. So as you can see that this x square, first of all, the x square did not appear as x square in the output, right? And secondly, we wanted this x square plus 2 to be in the power, but this plus 2 turned out to be outside the power, right? Why does this happen? Because in general, after a caret, when you write down a superscript, LaTeX in general takes only the first term. It will only consider this x as the power of the statement, right? It won't consider the square and the 2. So in that case, what you have to do is, whatever the power is, you want to put that inside curly brackets, right? So if I make the slight change, you'll see that this turns out to be e power x square plus 2, right? So LaTeX understood that the power in this case is x square plus 2, right? So that is one thing. You can have a tower of power if you want. It could be e power x to the power x and so on and so forth, right? So yeah, right? So it could be something like this. So this is basically the idea behind superscripts. Now coming to the next part, which is subscripts. For subscripts, it's kind of intuitive that we want to use underscore, right? For example, we have a bunch of variables. Let's say we have integers x1, comma x2, dot 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 till xn. So in this case, if you look at the output, you'll see that you got a bunch of variables where the subscripts are 1, 2, 3, and so on and so forth, all the way till n. This is how you use subscripts. Again, similarly, in this case, if you want to write two subscripts or something like that, for example, it could be x subscript 1, subscript 1. Let's see what does LaTeX give us as the output. You can see exactly like superscript, LaTeX only considers the first term after the subscript to be the subscript. So if you want a tower of subscript, or if you want continued subscript in the subscript, essentially, you'll have to put it inside curly brackets. So if you look at this, you'll see it's x subscript 1, subscript 1, right? So it's pretty similar for both the cases. Just remember, you have to use a caret for a power and a underscore for subscript. Alright, before we proceed any further, if you can recall, at the beginning of this video, I told you there are two ways in which you can create a LaTeX file. One is online, which we are currently doing on Overleaf. And the second thing is you can do it offline. You can download some application which supports LaTeX files and allows you to create them, and you can run your LaTeX file over there. You can create new files over there. So let's quickly look at what are the possible options. So if you go to your web browser, you can search these two names. One of them is known as TechMaker. So TechMaker is probably the one that's used by any offline user in Windows. It's not extremely friendly with the Mac OS. If you're on a Windows based device, you can I'll definitely recommend TechMaker for you. The other one which I'm going to be using in this video is known as TechShop. This is one which every Mac user uses. It's by the University of Oregon, and you can use this. It's extremely nice. But if I had to make a comparison between TechMaker and TechShop, TechShop doesn't really have recommendations for you when you're typing. For example, if you notice over here in Overleaf, when you try to write something, for example, I could be writing some I could be writing alpha, for example. You can see that there are a bunch of recommendations that the IDE provides you, right? It will give you the recommended things that start with the letters A, L, and P, right? But this thing is not really available on TechShop. So TechShop is in general used by experienced LaTeX users who want to flex their skills, okay, in some sense. But TechMaker does have this feature, okay? So if you're new and you want to do it offline, you want to store your files offline, then I would definitely recommend TechMaker to you, all right? Right, so now we'll quickly move over to the offline version because I'm more used to that, and there's not really a lot of difference. I mean, the basic idea is the same. The codes, the structure, the way you write down your tech files, they are the same, right? So as you can see, I have TechShop downloaded over here. So what you need to do is, so I'll just create a new file. I'll just open it. It creates a new blank file. So from templates, I'm going to choose LaTeX template. This is going to be helpful for people who want to use TechShop in the future. If you're not, this is readily available whichever application you're using. This blank template is in general freely available to you, so you don't have to worry about that. This is one line that I wanted to tell you about. If you carefully look at this line, use package, parfill, and parskip, what this basically does is it basically makes sure that all your paragraphs are aligned. Okay, it makes sure that all your paragraphs are left aligned, right? If you look at this, it's not really aligned, right? And we want our document to look pretty, right? Because that's the entire point of using LaTeX. So even if you're using overleaf, it's not there by default in the blank templates. I would recommend you to remember this code. I would recommend you to remember this line and put it in the preface of the code whenever possible, all right? So as you can see that it's pretty similar. We have the document class. Over here, you can see that there is a preset font size, okay? It's 11 point. If you want, you can increase it to 12 or 13. Let's go with 15 for this video, right? It's an article once again, right? Use package geometry, we'll come to this later. As you can see that there's a lot of description given on the right hand side, which tells you what each package does. Now, remember we talked about packages. So let's focus on this line. Use package AMS symbol. This package is extremely important if you're trying to use mathematical symbols. And if you are a math person who's using LaTeX for creating assignments or question papers or slides or whatever it might be, I would recommend you to basically have these three packages in your preface every time. AMS theme, AMS math, and AMS theme. So these are the contractions of these. So you want AMS math, AMS THM in your preface. We want to use this. Now, to compile this, basically it's pretty similar. I basically have to press compile, but because it's a new thing, it's not saved in my PC, so I'll have to save it under some name. So let's call it demo LaTeX tutorial, right? Let's just go with okay. So as you can see, it's again the same. Over here, it's a blank document, so it doesn't have a pre-given title or the author name, right? So let's do that again. We'll do the same thing what we did there. So let's call it LaTeX tutorial or demo, whatever you want to call it. I'll put my name here as the author. Okay, and the date, if you don't want it, you can just leave it blank. Yeah, so I'll compile this and you can see you get the demo thing. All right, cool. Once again, so over here it's commented, but let's just go with the subsection. Let's just go with section, and I'll just copy paste the code that we did on Overleaf, right? So just to give you a comparison between these two softwares. Okay, let's go with this. Yeah, let's copy this and let's paste it here. So if I compile this again, you can see you get the exact same thing, but over here you have this alignment that we talked about in the beginning of this video, right? Wonderful. So let's continue. So next thing we'll talk about is a little bit more about the mathematical symbols and equations that you can use, right? Alright, so continuing with this, so the next thing we'll talk about is, so over here if you notice carefully, we put in the equations in between the sentences, right? But what if you're writing something and you want to define something, some complex formula, how do you do that? So for that, let's just go with some statement. The Riemann sum of a function, let's say the function is from R to R. I might use some things that I haven't defined yet, but we'll come to that at a time, in a few minutes. So let's say it's a R to R function. So if I quickly compile this, you'll see that it tells you this, okay? So this is basically used for putting in spaces between lines, right? So I want a nice gap over here. So yeah, so suppose that you have a function from R to R and you want to define the Riemann sum of that. Let's go with the upper Riemann sum. Right, upper Riemann sum of that is define as. So basically what I want to do over here is that I want to define a formula in the next line. Okay, it's a big formula, it's some complex formula, and I don't really want it to be in the same sentence as the definition of it, right? So let's just write it with dollars first and see what is the difference, right? So it's defined as, let's say, UF comma with respect to some partition. We'll come to all these unknown things in a moment's time. So it's defined as a sum over, if you're a non-math user, I mean, it's fine. These are just mathematical definitions. You can ignore it for the time being. Okay, so the supremum, you can call it the supremum of F times delta I. Okay, it's a very, very contracted definition, but I think it'll serve the purpose of this video. Right, so something like this, right? Yeah, okay, wonderful. So as you can see that once I used single dollars, the equation turned out to be in the same line as the definitions, right? But what if I want to make it a little more elegant? So what I can do is I can use these, right? A slash followed by the square bracket, and what it does is it basically takes a definition to the next line, right? So this looks much better when you're defining something, right? So that is primarily the difference between these slash followed by a square bracket and dollar. So dollar basically keeps your equation in the same line in between text, whereas this basically takes the equation to the next line, right? So instead of this, you can also use something which is double dollars, okay? If this is, some people basically prefer double dollars. So even that does the same thing, okay? As you can see, there's no change in the output, so it does the exact same thing, right? Okay, wonderful. So moving on, as you can see, I've used a few terms over here. So let's quickly go over this. So the next thing we'll talk about is mathematical symbols. Yeah. Right. So there might be different mathematical symbols that you might need to use, okay? For example, it could be as simple as a summation, right? So sum is just simple sum, right? You can see you get a capital sigma over here, right? So sum is just sum. If you want product, however, if you want the pi product, you basically have to use either prod or you can use capital pi, right? So Greek letters are very simple to understand, right? Greek letters are very straightforward. So let's just create a subsection over here quickly and let's write Greek letters. Yeah. Okay. So Greek letters are very simple to use. Whatever the name of the Greek letter is, you basically write a slash in front of it, which basically tells LaTeX that it's a new thing. It's a command line that we want to use, right? So for example, if I want to write alpha, beta, followed by gamma, so I can just write these three, and you can see that alpha, beta, and gamma appear over here, right? So you basically need to know the letters. You need to know the name of the symbols if you want to use Greek letters, right? Similarly, if you want to use the capital version of these, for example, you might want to use capital gamma, just make sure that the first letter is capital, and LaTeX will realize that as the capital gamma, right? So you can see that we get a capital gamma over here, right? Yeah, wonderful. So this takes care of Greek letters. So coming back to mathematical symbols, it's very easily available. You can just Google list of mathematical symbols. In case you are a beginner, you can just Google the command for whatever mathematical symbol. So it could be the union. So union is basically written as cup, okay? If you use cup over here, you get the union symbol. And if you want intersection, it will be cap, okay? It could be as simple as this, and so on and so forth, right? But one thing you'll notice is that if you write the union, so let's say, one more thing. So yeah, let's quickly go over this. So like we talked about superscript and subscript in the first section of this video, in general summation product, these also have their own superscript and subscript, like the lower limit and the upper limit, right? So for that, we use the same notion, right? For example, if I want to add from I equal to 1 to n, let's say the sum of n numbers. So all I'll use is this, right? So as you can see, the lower limit is I equal to 1, the upper limit is n. So the subscript basically acts as the lower limit, right? So if I remove this console, you can see over here, yeah, this underscore followed by whatever you write it there, that is basically the lower limit of your summation or whatever operation it might be, right? And the caret basically acts as the upper limit of the operation, right? It could also be the product. You do the same thing. It could be product I equal to 1 to 2 n, let's say. Let's say, I don't know, let's just make it a little more complicated. So fi, okay? So this gives you the product of I equal to 1 to n f of I, right? It could also be the intersection of n elements. So I'll show you one more thing that I wanted to show you using this example. So it could be cup I equal to 1 to n, let's say xi, okay? So the union of n, Right. So we can see that if you use cup, essentially, these lower limits and the upper limit, they don't really look very fancy, right? They appear beside the symbol rather than being below and above the symbol, right? So what you can do for that is you can use big cup, right? So we use big cup, basically solves your problem, right? We want our cup to be bigger and it looks perfect, right? The place where you're going to use this most frequently is when you're trying to define the integral in some sense, right? So area under the curve or just a simple integral. So integral is given by int. It could be I equal to 1 to n. Let's say I equal to 1 to n fx dx, right? So that's how you write the integral. So if I zoom out, you can see it's there on the next page. Yeah. So I equal to 1 to n fx dx. Okay. Sorry, I went with the same thing that I was writing everywhere, but yeah. Basically, this is the lower limit of the integral and this is the upper limit. For the derivative, I have to define one new thing, which is fractions. How exactly do we write fractions in LaTeX? So LaTeX fractions are basically written as frac followed by 2 curly brackets, right? So whatever you write in between these first pair of curly brackets is the numerator of the fraction, and whatever you write in the second pair of the curly brackets is known as it's basically the denominator of the fraction, right? So if I want to write half, it's basically going to look like this, right? Okay. This is one version of writing a fraction. You can also use dfrac, which is slightly more elegant, right? So you can see it increases the size of it, right? So let's quickly compare these two in a sentence. The probability of a head is, let's go with dfrac half, and let's use the same sentence again. And the probability of tails is also, yeah, okay. So you can see clearly dfrac is the one you want to use if you want your fraction to appear bigger. Coming back to the next subsection, we were talking about Greek letters, okay? So Greek letters are pretty easy to use as long as you know the name of the Greek letter, you can basically write it down in LaTeX, alright? The next thing you want to use is basically mathematical functions, right? For example, trigonometric functions, logarithmic functions, and so on and so forth, right? How do we do that? So for that, let's define a new subsection, right? And yeah. So let's define it to be functions, right? Right. Okay, so trigonometric functions are very easy. You just write backslash sine x, you'll get sine of x, right? Okay, so you get sine x. Similarly, you can do it for cos. And right, so sine, cos, and tan. Okay. Cosec is the only one apparently LaTeX does not recognize. So if you want to use cosec, you have to go with CSC. Okay, because I'll show you a comparison, like cosec doesn't really work in LaTeX for some reason. So as you can see, cosec is not really recognized by LaTeX, so you have to use CSC, alright? Moving on, for using logarithmic functions, you can either go with backslash log. And if you want to use ln, you can basically use backslash ln. Yeah, right? So e power x is very simple to use. It's basically normal e power x, right? So these are some standard functions that you might need to use. Apart from this, if you are using something that's not very common, once again I'll tell you, just go up to Google, just search for what is the LaTeX symbol for blah blah blah, and you'll get it, okay? Anyways, the next thing, which is surprisingly very important, is using brackets in LaTeX. Okay, so it's simple. Normal brackets, first brackets are very easy to use, right? So if you want to use first bracket text, you can just simply straightforward write it, okay? Second brackets, again, the same idea, okay? So even second brackets is normal, but third bracket is not really very straightforward to use. For example, if I write third bracket x, LaTeX does not do anything because this third brackets are in general reserved for other things, right? For example, when you use frac, when you use underscore and caret, you basically use a third brackets to make LaTeX realize that this is your underscript or your superscript, right? So for third bracket, what you need to do is you basically need to put a slash in front of these for LaTeX to understand that you want to use the curly brackets, right? So as you can see, once I put the dashes, LaTeX does understand, right? Alright, cool. Now, what happens if you want to use brackets in a complex fraction? Okay, it could be it could be as simple as frac of, let's say, 1 by 1 plus x. So as you can see, this bracket is comparatively smaller than the fraction, right? So it looks horrible, to be very honest, in your LaTeX file. So what you need to do is you basically need to tell LaTeX how big you want your brackets to be, right? It's as simple as that. LaTeX is basically something you basically instruct it to do something and it will do it for you, right? So I want to tell LaTeX how big my bracket has to be. So for that, I just write big bracket in front of this. I just write big in front of this. Okay, so as you can see, the size slightly increased, but it's still not enough. So what I can do is use capital BIG, and you'll see that this is slightly bigger, right? And if I want even bigger brackets, I use BIGG. Right, as you can see, this is the largest form of the brackets. Okay, so it's as simple as that. Okay, so if you want to use bigger brackets, you just need to tell LaTeX that you want to use bigger brackets. It's as simple as that. Okay, so the three versions that we use are, I'll just write it here, big, capital BIG, and capital BIGG, right? So these are the three versions of LaTeX bracket sizes that we use in LaTeX. One more thing, if you want to add a comment in between the lines, okay, when you're like coding in LaTeX and you don't want it to be visible in the output file, then all you can do is basically comment this line. And for that, what you need to use is you basically put a percentage sign in front of it, right? As you can see, even though it's there in the code, even though it's, I mean, basically underlighted in some sense, but you can still read it when you're writing the code, right? So for example, if you want to add notes for yourself that you want to refer to later, you can just comment the line. Okay, it's not going to be visible in the output file, but it's there for your reference. All right. So the next thing we're going to talk about is how to create tables in LaTeX. Okay, so let's create a new section. Let's call it tables. Okay, cool. So for tables, what you need to do is, first of all, you want it to be inside these square brackets. Okay, so what you want to do is you basically want to tell LaTeX that you are actually starting a table over here. So for that, you define this environment, which is known as begin tabular and end tabular. Okay. Okay, so this basically tells LaTeX that you are creating the table in between these two lines. Okay, so there's nothing in the table, so obviously there's not going to be any output. But the next thing you want to do is you want to tell LaTeX that how many columns your table actually has. For example, let's assume that we are creating a table with just 2 columns. Okay, so let's go with C hyphen C, type C, and yeah. Okay, and let's go with A and B. Yeah, as you can see that we created a very lame looking table which has 2 columns which are separated by 1 line. Okay, I put a full stop by mistake. So yeah, this is what LaTeX has created for you. Alright, but now let's say you want it to look like a proper table. So what you want for that is you want a line in front of the first A and after the B, right? So what you do is you just put a line in front of C and one after C. Okay, so if you compile this, you'll see that you get 2 additional lines, but you're still missing the horizontal line on the top and the bottom. So for that, what you need to do is you just need to add a H line, ensure that you go to the next line and add a H line again. Okay. As you can see that it created a very small looking table which only has 1 row and 2 different columns, right? So this H line basically basically draw the 2 horizontal lines. This double backslash basically tells LaTeX that you have to move on to the next line. Okay, it's basically for changing the line, that's it. So assume that you have more elements in this. For example, let's go with C and D. And basically is used to separate the elements, right, from different columns, because you just write A and B, LaTeX is going to assume that A and B are the elements of the first column, right? So let's go with C and D, and you can see that you created a table which looks something like this. There should have been a H line in between these 2 as well. Yeah. Wonderful. So this is a very simple 2x2 looking table, and if you want to create longer tables, you have to adjust your settings accordingly. You have to increase the number of columns, you have to write on more elements, and so on and so forth, right? So this covers the part of using tables. The next thing we're going to talk about, so as you can see, we are going over the very basic briefs, okay? And in case you want to look into more detailed stuff, more advanced table creation and anything like that, you can basically go back to this site, the overleaf tutorials thing, and you'll see that everything is given over here, right? How to use LaTeX, the different forms, and so on and so forth. There are also a lot of FAQs given on the left hand side, and so on and so forth, so you can use that. And this is just to give you a brief idea how to use the LaTeX interface, how to create files, what exactly is compiling, how do you write simple mathematical equations, and so on and so forth, right? So going back to our file, the next thing we'll talk about is creating lists. Okay, for example, if you want to list down a bunch of things, what you can do is begin itemize and end itemize. Okay, so what basically you do after this is you write down item. Okay, so as you can see, it basically creates bullet points, right? So let's see what are the things that I have to do today. Create a tutorial, get better at LaTeX, let's say these are the two things I have to do today. So as you can see, I created a bulleted list which has these two things as the elements. Now let's say you want to number these, right? So if you want to number this, the simple thing you have to do is instead of itemize, you use enumerate, right? So you want to enumerate the things that you want to do. So the next thing, and which is probably the last thing you need right now for creating simple, I mean, it could be assignments or slides in LaTeX, is how to align equations, right? So for that, let's create a new section, alignment. Okay. Now there are different versions of alignment that you can, there are different versions of alignment that you can use in LaTeX. So let's go with a simple one. So we want to define our alignment environment. So let's go with aligned and end aligned. Okay. So this basically tells LaTeX that whatever equations are there inside this environment need to be aligned properly. So let's write down a bunch of gibberish, okay, just for the sake of this. So let's go with integral x equal to a to b fx dx equal to some alpha beta equal to pi mu delta equal to gamma mu. Let's go with something like this. So as you can see, it's a bunch of gibberish all written in the same line, right? But for example, you might need these equations, these equations in between the equal to's could be slightly larger, so you want them to be in different lines. So for that, what you do is, you start off with a pivot, right? So for example, this first equal to might be the reference point with respect to which you align the equations, right? So to tell that to LaTeX, all you have to do is you need to put an and in front of the first equal to. And coming to the next line where you want to break it off, what you do is, you put a double backslash followed by an and what LaTeX will do is it will take this equation to the next line. For example, you can see that with respect to this equal to in between, the next equal to is exactly aligned next to it and the following equations come after that. So if you want this last thing to be in the next line, you can also do that. You basically put a double backslash and you write and in front of it, right? So as you can see that all these equations are aligned with respect to the equal to in between. So these are basically the major things that you need to know right now for creating a very simple LaTeX file. For example, something like this, even though it looks horrible, it's not aligned. It's a bunch of things that I've written down to help you guys. So if you want a more detailed video or if you want to know more about different things that you can actually do with LaTeX, please do let us know in the comments. See you.